Now what we're going to do is take all the things that we've been talking about for the last 6 videos, and we're going to put it together to solve some questions about chemistry. So the area of chemistry that we're studying right now is called stoichiometry. And stoichiometry, the way that we define this is the quantitative study of reactants and products in a chemical reaction. So think of it this way. If you're reading a recipe, and let's say you're going to make a cake. You read the recipe card on the back of the box. It tells you how to bake the cake. In order to make one cake, you got to have 2 eggs, a cup of flour, a cup of sugar. Will make this really sweet, and a bunch of other stuff. Okay, so if you add all those ingredients all at once, that makes your cake. Okay, so what if, let's say, you didn't have enough for one cake, or you had, like, instead of 2 eggs, you had 1 egg, or something like that? Well, we can do the same thing with chemical reactions. So think of a chemical equation as like a recipe card. And what if you didn't have 2 moles of something in order to make a reaction go? We can still try to figure out how much cake or how much product is going to be made. So the way that we solve stoichiometry problems, we use a method called the mole method. And the way this works is that we go back to the chemical equation and we take a look at the coefficients, and we use the coefficients as conversion factors from one species to another. Okay, so the stoichiometric coefficients in a chemical equation can actually be interpreted as the number of moles for each substance. So let's try out a problem. So here's our problem. Methanol burns in air according to the following equation. 2 moles of methanol plus 3 moles of oxygen yields 2 moles of carbon dioxide and 4 moles of water. Okay, now if you have 209 grams of methanol and they're used up in this combustion process, what is the mass of water produced? Okay, so what do we know? We know that we've got grams of methanol. So that's where we're starting with. And I'm going to shorthand methanol as MEOH. Okay, so we know we have grams of methanol. In order to start this off, the first step was that we convert from grams of methanol to moles of methanol. Because before we can do anything else, we need to get to moles. Okay, and to do that conversion, we're going to need the molecular weight of methanol. Now, once we're in moles of methanol, we can convert to moles of water, because we have to use the equation to do that. Okay. And so if you look at the coefficients, you've got 2 in front of methanol, you've got 4 in front of water. So you know that this ratio is going to be 2 to 4. Okay. Finally, when you're in moles of water, you're going to convert that to grams of water. And the number that we need for that, we need the molecular weight of water. All right. So that's pretty much our game plan of how we're going to solve this problem. All right, so let's start this off. So if we know we've got 209 grams of methanol, we need to convert this to moles of methanol. We need to put the grams on the bottom so that way they cancel out with the 209 grams. All right, so if we calculate the molecular weight of methanol, that number comes out to be 32.04 grams. Okay, so that way grams of methanol cancel out. Now, here's the part that trips a lot of people up. How do you go from moles of methanol to moles of water? So yes, I'm saying you're going to use the chemical equation to do this. We're going to do it just like the last step. We're going to make another fraction. We want to put moles of methanol on the bottom, so that way it cancels out with moles of methanol on the top, okay, of the previous fraction. and I'm going to make moles of water on the top of that fraction. So according to the chemical equation, you've got 2 moles of methanol for full 4 moles of water. So those are the numbers I'm going to put. 2 on the bottom, 4 on top. All right, so unit-wise, now we're in moles of water. We need to convert this to grams of water. So I need to put 1 mole of water on the bottom, so that way moles of water cancel out. On the top of that fraction, we need to put the molecular weight of water, which is going to be 18.02 grams. Okay. Now notice, when we're all said and done, the unit that we're left with is grams of water. So we know that's how we got the, we got the right answer. So the math should check out. The only thing is that could trip us up now is if we make a math error. All right, but let's try this out. If you got 209 times 4 times 18.02 divided by the total the product of 32.04 times 2, that number I get should be 235 grams of water. All right, and so there is your answer to that problem. Let's try another one. The reaction between nitric oxide and oxygen to form nitrogen dioxide is a key step in photochemical smog formation. And here's the equation. 2 moles of nitric oxide plus 1 mole of O2 yields 2 moles of NO2. How many grams of O2 are needed to produce 2.21 grams of NO2? So this problem's a little bit different in that we're starting with a product and we're going to the reactant. So the setup is going to be pretty similar to what we just did in the last product, in the last problem. We're going to start with grams of NO2, and what we're going to do is convert that from grams of NO2 to moles of NO2. Once we're in moles of NO2, we can convert to moles of oxygen, okay, and then we'll convert that to grams of oxygen. All right, now how do we do all this? So to convert from grams of NO2 to moles of NO2, we need the molecular weight of NO2 to make that happen. To go from moles of NO2 to moles of O2, we need to use the chemical equation. And if you look at the coefficients, you've got 2 for NO2, and you've got a coefficient of 1 for O2, so that's going to be a ratio 2 to 1. All right, and to convert from moles of O2 to grams of O2, we need the molecular weight of O2. All right, so that's our game plan. So let's try this out. All right, so we know we've got, let's start with a 2.21 grams of NO2. Okay. All right, we need to convert that from grams to moles. So I need moles on top. So 1 mole of NO2. We need grams on the bottom. And the molar mass of nitric oxide, or I'm sorry, nitrogen dioxide is 46.0055 grams NO2. So that way the grams of NO2 cancel out. We're already in moles of NO2. All right, we need to convert from moles of NO2 to moles of oxygen. So we're going to use the equation for this. So I'm going to say moles of oxygen on the top, moles of NO2 on the bottom, so that way the moles of NO2 cancel out. The number, according to the chemical equation, you got 2 moles of NO2 to 1 mole of O2, so I'm going to write 1 over 2. 1 mole of O2 over 2 moles of NO2. All right, now I need to convert from moles of O2 to grams of O2. I need the molar mass for this. I'm going to put 1 mole of O2 on the bottom, so that way moles of O2 cancel out. We need to put the molar mass here on the top, and that molar mass comes out to be 32 even. Okay, so math-wise, it's 2.21 times 32 divided by the product of 46.0055 times 2, or the number comes out to be 0.769 grams of O2. And so that's how you use the mole method.